Hello! Looking in at 2.2, we're looking at translations of basic graphs. And the graphs we're looking at are the square graph, as you can see here. It's a parabola. It's also an even function, as it is reflexive around the y-axis. We have the square root function, as you see here. And we have the cubic function, as you see here in green. It is also an odd function. It is symmetric about the origin. And we have the absolute value function, and this is also an even function as it is symmetric to the y-axis. And then the basic translations that we're going to apply to all of these basic graphs. So they're going to maintain these shapes, and we're just simply going to move them horizontally, left or right, or we're going to move them vertically, up and down. And these are the variables that allow this to happen. So in our basic equation, this is an example in a square function because it is squared. We're going to have x minus, as you see, what's in black stays there, unless, of course, this changes to cubic or it changes to a square root or an absolute value. We are going to be subtracting whatever our h value is. So this can change from plus to minus depending on what this value of h is. And then we're going to be adding or subtracting depending on the value of this k, and this is going to tell us to either go up or down. So we look in this first one here, we are writing a function. It is a squaring function, which means we have it squared, and we're shifting it 4 units downward. So our k is -4, and we're simply writing it like so. In this next one here, we're looking at the absolute value function, and we are moving it 2 units to the left, so our h is equal to -2. So I have that x minus, excuse me, my h value, which is -2, and then when I simplify that, I get the answer here, c. In this next one, we can see here that k is equal to -3. That means I am moving a square function or a parabola down 3, as you see there in c. In this next one, we have horizontal movement. Our h is 3. Our vertical movement is -2, so we're moving to the right and down 2 for an absolute value function. It has that V shape. And then our next one, we have a cubic function. So you can see the blue one represents the basic f of x is equal to x cubed. And then we are applying moving to the left or moving towards -3, as you can see here in red in A. Here we have our h is equal to 2, so we're moving to the right. Here we have our k equal to -3, so we are going down. So the basic cubic shape, as you see here in blue, is moving to the right 2 and down 3 for our very nice fuchsia cubic function there. So that is in B. Next one, we have a square function, and we have a k value of -2, so we're simply moving it down 2 as illustrated here. It's asking us what our domain. It is obviously -infinity to infinity because I can plug in any x value. But we also see we do have a bottom floor here at -2. So we need to use a bracket there, -2 towards positive infinity up, and that is our range. Here we are graphing. If you need me to show you how to use this graphing tool, it's really easy. But our square function, beautifully drawn here. As you can see, we are moving towards -3. So we move from the origin to here, and our vertex remains there. And we have a parabola, very nicely drawn there. Here we have a cubic function, so it should have this little shape here. We have a horizontal movement towards -5. So here we see it says +5, but that means minus -5. So I'm moving to the left, and we simply draw our cubic function. We're doing the same here, our k, which means we're going up 5 for an absolute value, so we need that V shape here. As you can see, we just simply moved up 5. And the next one, we have horizontal movement towards 3 and vertical towards 5, so we're moving right 3 up 5, and here's our square root graph. As you can see, it's not whole because we can't take the square root of negative numbers. So everything to the left of 3 would give us a negative number in there. We just can't have it. Here we're looking at the absolute value, so we have that V shape. We are moving, as you can see, we have +6, which means that's minus -6. So our H is -6. We're moving to the left 6. Our K, or vertical, is -6, so we go down 6, and there's our graph. Here we have this function that they're calling f of x, and then we're subtracting 1, which means our k is -1. So this whole thing is moving down 1. Every point on this graph is moving down 1. As you can see illustrated here in C, we've simply moved it down. In this next one, we are writing this. We see that it is a parabola. Therefore, we are using a square function. We see that our vertex here is at -4, +1, so our h is -4. So when writing this equation, we have x minus -4, which becomes x plus 4. Don't forget your square. And then we're going up 1. Then we're talking about increasing and decreasing here. So we have to look at as we're moving from left to right. So increasing begins at the x value of -4. And as we know, we do not use any type of brackets here. So for the increasing, it begins at the x value of 4, and then it goes on for infinity. And then for our decreasing, that begins at -infinity, and that stops also at 4. Now that can be confusing because you say, well, Mr. Ham, it's coming from up here. It's coming from positive infinity. But I ask you this, what x values are those, right? So as we're going up on that graph to the left, we are looking at negative x value. So everything we write about outside of range is talking about our x values. On this next one, we are looking at a cubic function, and we see we have no lateral movement, nothing left to right, so that's 0, and we're moving up 5. And when we write that, make sure we have the cubic function x cubed, and we're adding 5. And for this next one, very simple. We just simply look at this vertex, -5, -3. The -5 is our h, and the -3 is our k.